Okay, today's note's 315. Let's just start off with our do now, which is factoring. We have lots of ways to factor. The way we've been kind of working on in class is what I would call the 5-step method. The first thing you do is take the A and the C and you multiply them together. A times C, that's 2 times -6, is -12. And then your algebra teacher asks you to put the -12 in the top of your X. And then the number she asks you to put in the bottom would be the B, which is 1. We're looking for two numbers that add together to give you 1, but those same two numbers have to multiply together to give you -12. So we got -3 and +4. Since the A is not 1, it's 2, we have to take the -3 and the 4 and divide it by 2. The bottom number is what is the coefficient that goes in front of the X in your factor. So this first fraction turns to 2x minus 3. That's my first factor. Now the second equation, or the second fraction, 4 over 2, actually reduces to 2 over 1, and the bottom number gets the x, so it's going to be 1x. We just write that as x, and then the top is plus 2. So here are your factors. We just have a few more things to learn about circle relationships. We've got 3 rules. The first one I want to talk to you about is not on this slide, so I'm just going to actually draw it in. This is called the Chord theorem. On the chord theorem, we're going to start with a circle because in order to have a chord, you also have to have a circle. I'm going to draw in 2 chords. I'm just going to label these chords A, B, C, D, and E, all the parts, okay? So A, D is one chord, B, E is the second chord. Really simple rule to follow. If I take A to C, that part of chord AD, and I multiply that by the other part of the chord AD, so in this case, the other part is going to be CD, that will equal the other 2 parts of the second chord multiplied together. So what are my other 2 parts? BC is one of them. So we're going to take the distance from B to C, and we're going to multiply that by the distance from C to E. So you're just taking both parts on both chords, multiplying them together, and when you do that, those 2 products will equal each other. On the picture above, this one is called the secant rule. If you look, we actually have 2 secant lines. The first secant line, and it's really technically a segment, is AE. The other secant segment is CD. If you look at AE, that secant has a part that's on the inside, and that also has a part that's on the outside. BE just so happens to be the outside part. If I look at secant line segment CE, the part that falls on the outside is DE. So if I take the outside of the secant, so I'll choose secant AE, so I'm taking the outside part, which is BE, and I'm going to multiply that by the total secant lines. The total secant line is A to E. Total, the whole thing. The total is going to be AB plus whatever BE is. This will equal the outside of the other secant line, which is DE, that distance, times the total of the other secant line, the total length, which in our case is CE. If I want to get the total length CE, all I do is take CD and DE and add them together to get the total. The third rule is called the secant tangent product theorem. The reason is because I still have a secant line, and this secant line still follows the original rule, which is we take the outside of the secant line and we multiply that by the total secant, which in our case will be A to C, the total. And since the other line is a tangent, we're just going to take the tangent line and we're going to square it. So it's going to be the distance from D to C squared. The reason why we're squaring it is because it follows the secant rule, which is outside times total. And that tangent, the outside and the total length are the same number. To multiply the same number by itself, that just means to square it. So let's try some examples. Okay, first example, I've got two chords. On my picture, PQ is 6, QR is 4, QT is 8, and we're trying to find S to Q. That's my X value. Since this is the chord, the rule is I take part times part of one chord, and that's going to equal part times part on the other chord. So my two parts on PR are 6 and 4. So I'm going to do 6 times 4. And that's going to equal my two parts on my other chord, which are 8 times X. 6 times 4 is 24. That's going to equal 8X. Divide both by 8 and X equals 3. You too. So how long is P to R? 6 plus 4 is 10. How long is S to T? 3 plus 8, which is 11. Notice how they're not the same length, but the product of their parts are what is congruent. On the next example, we have two secant lines. So the rule is going to be outside times total. So let's label what we got. R to S is 4. S to T is 6. P to R is 5. And P to Q is X. So I take the outside. Let's focus on TR first. So I take the outside of TR, which is 4. We're going to multiply that by the total. In our case, our total is going to be from T all the way to R. That's my total. So that's going to be 10 because 6 plus 4 is 10. And we're going to set that equal to the outside again of the second secant line, which is 5, times the total of that secant line. Well, from Q to R to get the total, we're going to add QP and PR. So that's X plus 5. So my total is actually X plus 5. So I get 4 times 10, which is 40, equals 5X plus 25. work out your algebra. And we get x equals 3. TR is just going to be 10. We already discussed that. But Q to R is going to be 8. They're not the same length, but their products of the outside times the total will equal each other. Last but not least, I've got an example of a tangent in a secant. So the secant follows the same rule. We need a total, which will be 5 plus 4, which is 9. And then we need the outside piece, which is 4. So we do outside times total, so 4 times 9. And that's going to equal the tangent line squared. 4 times 9 is 36, equals x squared. Take the square root of both sides, and x equals 6.